Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about Impulse Invariance Method of designing an IIR filter. So first, the steps to designing Impulse Invariance Method. First step is, from the given specification, find HAFS, there is a transfer function of an analog filter. So for analog filter design, we have already seen two methods. So any one method can be used to find that HAFS. This is the transfer function of analog filter. Second step, select the sampling rate of the digital filter t seconds per sample. So normally they give it in a problem. If they are not given, you assume t is equal to 1. Third step, express the analog filter transfer function as a sum of single pole filters. So look at this format. HAFS should be equal to summation of k is equal to 1 to n Ck divided by S minus Pk. That is summation of single pole filters will be founded. And fourth step, compute Z transform of the digital filter by using the formula. Look at this step 3 and step 4. So from this they will map to H of Z. So H of Z equal to summation of k is equal to 1 to n. So Ck divided by 1 minus e power Pk into Z divided by Z power minus n. Look at this. So here we have S minus Pk. No, the same thing that will be substituted e power Pk into the sampling rate t. So for a higher sampling rate, we need to use this H of Z equal to summation of k is equal to 1 to n t into Ck divided by 1 minus e power Pkt into Z power minus. So this is the steps to design an impulse invariance method of IIR filter in digital form. Look at the given problem. So for the given analog transfer function H of S equal to 2 divided by S plus 1 into S plus 2, determine the H of Z using impulse invariance method. Here that analog filter design is already completed. They given a final result of analog filter H of S. So they just ask you to find H of Z using this impulse invariant method. So first thing, given H of S equal to 2 divided by S plus 1 into S plus 2. So from this I can use a partial fraction method to find the values. So I am taking H of Z equal to A divided by S plus 1 plus B divided by S plus 2. So this value will be equal to 2 divided by S plus 1 into S plus 2. So look at this, how I am mapping this. So A equal to S plus 1 because the expression is in multiply with S plus 1. So into 2 divided by S plus 1 into S plus 2 where S equal to minus 1. So because S equal to 1 no, so if you bring that S equal to minus 1. So that's why I am substituting S equal to minus 1. That expression should be removed. That's why I am multiplying with the S plus 1. So these S plus 1 and this S plus 1 will be cancelled. Only we get 2 divided by S plus 2. So 2 divided by S plus 2 we substitute minus 1. So 2 divided by minus 1 plus 2. So that's the value we get it. So minus 1 plus 2 that will be becomes 1. So 2 divided by 1 that will be equal to 2. So A equal to 2 the final answer. And similarly I am going to find B value. So S plus 2 into 2 divided by S plus 1 into S plus 2 where S equal to minus 2. So once if you substitute it, first this S plus 2 and this S plus 2 will be cancelled. So we have only 2 divided by S plus 1. So instead of 2 we need to substitute S is minus 2 here. So minus 2 plus 1, so that will be equal to minus 1. So 2 divided by minus 1 that will be equal to minus 2. So A equal to 2, B equal to minus 2. Just replace it. So H of Z equal to A divided by S plus 1 plus B divided by S plus 2 no. So here A should be replaced by 2 and B should be replaced by minus 2. So that's why this expression becomes 2 divided by S plus 1 minus 2 divided by S plus 2. Now this is not in the form of S minus that poles. So that's why I am going to change it. Plus 1 is changed to minus of minus 1. So look at this, 2 divided by minus of minus 1 minus 2 into S minus of minus 2. So now we can match with this. So H of Z equal to summation of k is equal to 1 to n Ck divided by S minus Pk. So now this is in the form of this. So same thing, this also will be in the form of, by using this we can write H of Z equal to k is equal to 1 to n Ck divided by 1 minus e power Pkt into Z power 1. So now we can apply this. Look at this. So I am going to apply this 1 minus e power Pkt into Z power minus 1. So P1 is minus 1 and P2 is minus 2. So I am substituting this H of Z equal to 2 divided by 1 minus e power t because the value will be 1. So into z power minus 1 minus 2 into 1 minus e power here minus 2. So minus 2 to t into z power minus 1. So t equal to 1 we can substitute it. So you get 1 minus e power minus 1 z power minus 1 minus 2 divided by 1 minus e power minus 2 into z power minus 2. Just substitute the calculator value. You get 2 divided by 1 minus 0.3678 into z power minus 1 minus 2 into 1 minus 0.1357 z power minus 1. Now cross multiplying these two, we get this h of z equal to 0.465 z power minus 1 divided by 1 minus 0.503 z power minus 1 plus 0.04976 z power minus 2. Thank you.